The Sun. A blazing ball of plasma that dominates our sky. This celestial giant is the reason for our existence. Without the Sun's energy, life on Earth would be impossible. All life traces back to the Sun's warmth. Its gravitational pull keeps our planet in orbit, defining our year and seasons. Let's explore this magnificent star that graces our sky. Deep within the Sun's core, a process of unimaginable power unfolds. Nuclear fusion. This is the engine that drives the Sun, transforming hydrogen into helium and releasing an incredible amount of energy in the process. Imagine the power of countless atomic bombs detonating every second. This is the scale of the Sun's nuclear furnace. The process begins with hydrogen atoms, the simplest and most abundant element in the universe. Under the immense pressure and heat of the Sun's core, these atoms are stripped of their electrons, forming a sea of charged particles called plasma. In this extreme environment, hydrogen nuclei are forced to fuse, creating helium and releasing energy in the form of light and heat. This energy, in the form of photons, then embarks on a long and arduous journey from the Sun's core to its surface. This journey can take hundreds of thousands of years as photons are constantly absorbed and re-emitted by the dense plasma. Eventually they escape into space, bathing our solar system in sunlight and warmth. The Sun is a complex structure with distinct layers, each playing a crucial role in generating and transporting energy. Think of it like an onion, with layers surrounding the central core. The radiative zone is where energy slowly makes its way outward through radiation. Above it lies the convective zone, where hot plasma rises, cools, and sinks like boiling water. This creates a pattern of granulation on the Sun's surface. Finally, the Sun's atmosphere has three main layers: the photosphere, chromosphere, and corona. The Sun's energy is the driving force behind Earth's climate. It warms our planet, powers the water cycle, and drives atmospheric circulation. The amount of solar energy Earth receives varies depending on the time of year and our planet's tilt, leading to the changing seasons. The Earth's tilted axis causes different regions to receive varying amounts of sunlight throughout the year. This delicate balance of incoming solar energy and outgoing heat is crucial for maintaining a habitable climate. Even slight variations in the Sun's energy output can have significant impacts on Earth's climate. For example, periods of low solar activity have been linked to cooler periods in Earth's history. Understanding the Sun's influence on Earth's climate is vital for predicting future climate change. By studying the Sun's past behavior and current activity, scientists can gain insights into how our climate might be affected by solar variability. Weather wonders. From sunshine to storms, the Sun's energy drives our daily weather. From gentle breezes to powerful storms, the Sun sets our atmosphere in motion. Uneven heating creates temperature differences that drive atmospheric circulation. Warm air rises, cool air sinks, creating convection currents. These currents transport heat and moisture, forming clouds, wind, and precipitation. The Sun's energy fuels the water cycle, leading to rain or snow. The Sun also powers hurricanes, drawing energy from warm ocean water. Section 6. Ancient astronomers, sun gods, and celestial deities. Since the dawn of civilization, humans have gazed upon the Sun with a mixture of awe and reverence. Ancient cultures recognized the Sun's vital role in their lives and often incorporated it into their mythologies and religious beliefs. Across diverse cultures, the Sun has been personified as a deity, often associated with life, warmth, and power. The ancient Egyptians, for example, worshipped Ra, the sun god, who sailed across the sky in a celestial boat, bringing light and warmth to the world. In Greek mythology, Helios, the sun god, drove a chariot of fire across the heavens, illuminating the day. And in Norse mythology, Sul, the sun goddess, rode a chariot pulled by two horses, chasing away the darkness. These myths and legends reflect the deep-seated human fascination with the sun and its celestial journey across the sky. They also highlight the profound influence the sun has had on human culture and our understanding of the cosmos. Section 7. Solar eclipses, celestial ballet and scientific inquiry. Few celestial events captivate the human imagination quite like a solar eclipse. This awe-inspiring spectacle occurs when the moon passes between the sun and earth, temporarily blocking out the sun's light. For a brief moment, day turns to twilight, and the sun's corona, usually invisible to the naked eye, becomes visible as a shimmering halo around the moon's silhouette. Throughout history, solar eclipses have been viewed with a mixture of wonder and fear. Many cultures attributed eclipses to supernatural beings or interpreted them as bad omens. However, with the development of astronomy, our understanding of these celestial events evolved. Solar eclipses provide a unique opportunity for scientists to study the sun's corona, which is normally too faint to observe against the glare of the sun's disk. During an eclipse, scientists can use specialized instruments to analyze the corona's composition and temperature, providing valuable insights into the sun's magnetic field and solar activity. Section 8. Solar flares and CMEs, the sun's explosive temper. The sun may appear calm and steady from our vantage point on Earth, but in reality it is a dynamic and often tempestuous star. The sun's surface is constantly in motion, with magnetic field lines twisting and snapping, releasing enormous amounts of energy in the form of solar flares and coronal mass ejections, or CMEs. Solar flares are sudden, intense bursts of radiation from the sun's surface, often associated with sunspots, which are cooler, darker regions on the sun's photosphere. CMEs, on the other hand, are massive eruptions of plasma and magnetic field from the sun's corona, capable of hurling billions of tons of material into space at incredible speeds. While most solar flares and CMEs pose no direct threat to life on Earth, they can disrupt radio communications, damage satellites, and even cause power outages. Understanding and predicting these solar storms is crucial for protecting our technological infrastructure and ensuring the safety of astronauts in space. Section 9. Unveiling the Sun's Secrets, Spacecraft and Telescopes. To unlock the Sun's mysteries, scientists have deployed a fleet of spacecraft and ground-based telescopes to observe our nearest star in unprecedented detail. These sophisticated instruments capture images of the Sun across various wavelengths, from visible light to X-rays, revealing different aspects of its dynamic behavior. One such mission is NASA's Parker Solar Probe, which is on a daring mission to touch the Sun. This spacecraft is making repeated close approaches to the Sun's corona, braving extreme temperatures and radiation to gather data on the solar wind, a stream of charged particles constantly flowing from the Sun. Ground-based solar telescopes, such as the Daniel K. Inouye Solar Telescope in Hawaii, provide another vantage point for studying the Sun. These telescopes are equipped with adaptive optics, which compensate for the blurring effects of Earth's atmosphere, allowing scientists to obtain incredibly sharp images of the Sun's surface. Section 10. The future of solar research, unanswered questions. Despite significant advances in solar physics, many questions about the Sun remain unanswered. Scientists are still working to understand the mechanisms that drive the Sun's 11-year cycle of activity, the origin of the solar wind, and the processes that heat the Sun's corona to millions of degrees. Future solar missions, such as the European Space Agency's Solar Orbiter, aim to address these questions by providing even more detailed observations of the Sun from different perspectives. The Solar Orbiter will capture the first ever images of the Sun's poles, offering insights into the Sun's magnetic field and its role in solar activity. By continuing to study the Sun, scientists hope to not only unravel the mysteries of our nearest star, but also gain a deeper understanding of the fundamental processes that govern the behavior of stars throughout the universe. Section 11. Our place in the Sun's warmth. As we wrap up our journey through the Sun's wonders, it's vital to ponder our position in the vast universe. This fiery sphere of plasma, though seemingly remote, is deeply intertwined with our existence, supplying the energy that sustains life on Earth. Grasping the essence of the Sun goes beyond mere academics. It's about valuing our place in the cosmos and acknowledging the delicate equilibrium that makes life on Earth feasible. Through studying the Sun, we enhance our comprehension of our planet's climate, weather, and the fundamental forces that shape our world. As we venture further into the universe and seek life beyond Earth, the Sun stands as a constant reminder of the preciousness and fragility of life in the vastness of space. Let us always cherish and value the life-giving warmth of our closest star.